First off, we are just super excited to be here. We are huge fans of Grafana. We've been using it for a while, so we'll share a little bit of how we're using it, but just wanted to say thanks for hosting us today and very excited to meet all of you guys virtually. As mentioned, we'll be around and we'll also leave our contact information. So if you have any questions at the end, feel free to email us or ping us at any point. So with that, Sam kicked us off. We're going to talk a little bit about what Agrology does and give you sort of a sense for our IoT solution in that space. But before we jump in, just really quick, want to do a quick round of introductions. So my name is Emma Sagan. I'm the COO here at Agrology. Pass it over to Tyler.
Hi, I'm Tyler Locke, the co-founder and CTO of Agrology.
And I'm James Ranson. I'm the founder of a cloud consulting firm called Virga that is providing Agrology's backend technology.
And James is amazing. Highly recommend if anyone's looking. Virgo is wonderful as well. So today what we're going to go through is just give you a quick overview of how Agrology helps growers. Growers, farmers, we're going to use that interchangeably, but it's essentially anyone who grows anything. We'll talk a little bit about our IoT approach and then go into how we use Grafana, and then we'll hold some time at the end. So we are going to do questions at the end. So with that, we've sort of touched upon this. Agrology helps growers make informed decisions based on their unique conditions. So for those who aren't familiar with the space, a lot of small and medium farmers don't have access to great data. And as a result, they don't have great access to predictive analytics. So it's sort of, if you think about the whole puzzle piece or the whole equation of, you know, I'm trying to figure out, am I going to irrigate today? Am I going to irrigate next week? What do I do in these situations? A lot of that today relies on sort of regional data, things that are produced by ag extension schools where they can go online and see, okay, it says in my giant region that I should water next week. Realistically, everyone's conditions are pretty unique. Your soil, your topography, everything like that really changes the game. And historically, sensors have been really expensive for the small and medium farmers. They're often priced out. They have, you know, challenges with adoption. It's a small operation, and so it's hard to use. And so we sort of looked at this equation and said, let's figure out how we help folks better understand their own fields. We are not farmers. We have too much humility to call ourselves that, and we're really here to try and help them do what they do best. But we wanted to give them sort of the tools that are at our disposal. So with that, I'll kind of go through the app a little bit, give you some context, and then we'll go from there. So our platform has two components, I should say really quick. The first is we looked at this problem and said, you need great data going in, and we built out a new type of sensor technology, which Tyler will talk about in a minute. The other side of this is we need to make it really easy to understand. And so that's where the app comes in. So the way we've structured this is you actually just pay us a monthly fee. You don't actually pay for the sensors. You don't have the upfront capital, which for a lot of farmers is sort of a barrier to entry. From there, essentially, that allows them to have access to this data in real time. So the first sort of area we focus on is just ensuring that you have all of the information going on across all of your farms in real time. Some of these folks have one location, some have many. What this allows you to do is go in and see every 30 minutes we update the data, and you're seeing what's happening under the ground. Our sensors are installed both under the ground, so you're seeing sort of soil moisture and things like that, and above the ground. So what are the air conditions, the humidity, are there fine particles? I happen to live in California where there are wildfires. So are you in the middle of smoke exposure? What does that look like? If we go to the next slide, you'll see that we also want to make sure that it's really easy to get alerted when there's an issue. We can talk a little bit about this on the back end, but we want to ensure we're not bombarding you with messages, but we want to make sure that if you need to take an action, you can, and you know what that might be. So if we're sensing a temperature spike, because we take our data, we combine that with local weather data, and we use that to sort of predict out what's going to happen in the future. We can say things like, you know, it's not going to rain next week, your soil moisture is going down, therefore we know your irrigation schedule says you should water in a week. We think you should water actually tomorrow to get ahead of it. And so we send you alert when that comes up. We also do this in the wildfire space. So, you know, a couple of our customers had wildfires unfortunately break out within 10 miles of their land this weekend, and we were able to let them know, hey, you've got smoke in your field, be prepared to, you know, monitor accordingly. And then on the last component here, and this is where this bleeds really nicely into a lot of Grafana, if you go to the next slide, you'll see that we also want to make sure that you really have control over your data, that you can see trends, you can look at different things that are happening in the field over time in a short period, and you have control over your own data. So this is a big thing in the farm community. We want to ensure that everything is encrypted and everything from a security perspective, but we also want to ensure farmers own their data. There have been players who've come in the past and sort of said the data on our platform is ours. As you can imagine, many tech companies do this. We don't. We actually don't share the information. We don't even have permission to look at it unless we explicitly get that from the farmer, and that's to protect them. There are situations where larger companies may change their fertilizer price based off of the conditions they know are happening in a farm. We never want to be in that situation. So data privacy is very important to us as well. So with that is a kind of brief overview of what the customer experience looks like at Agrology, and I'll pass it over to Tyler to talk about our hardware.
Awesome. Thank you, Emma. So this is a quick overview of the approach to our hardware, just to get a better sense of how we generate all the data that flows into our platform and our modeling inputs as well. So this device here is what we call our second generation ground truth array. Our design philosophy with these devices was to create low cost hardware that's very easy to use and to install for the end user. These devices primarily use consumer grade sensors. That price point is really important for us. What that allows us to do is increase our deployment density when we get out into a field. And that allows us to cover all of the different irrigation blocks and management zones that might exist on a particular farm or ranch. The price point that we achieved with these devices, it also allows us to utilize a higher hardware replacement rate. And we actually like that as opposed to keeping our devices in the field longer. It allows us to take advantage of new sensor technologies as they come available and constantly keep upgrading our hardware that's out in the field. So some of the data points that we collect, Emma mentioned some of these in the earlier slide, but we collect atmospheric data. So we collect information about the surrounding nanoclimate, including temperature, humidity. We have gas sensors on the device as well. We look at 4 points of data below the soil. So we're constantly looking at how water and nutrients are moving through the soil with these devices. We're also monitoring the irrigation system. So we really provide a form of auditing for the growers. So they have confidence that they're actually delivering the amount of water to each management zone that they're prescribing. And also we combine the data from these devices with external weather data as well that also feeds into our models. The devices themselves are powered by simple swappable AA batteries. We get over 5 years of life on a single charge with these devices, and they communicate to the platform using low power wide area networking. We use LoRaWAN, which is actually a pretty popular wireless networking spec for agriculture applications like ours in particular. And moving to the next slide. And here is just a simplified kind of 1,000-foot view of what our system architecture looks like as a whole with the platform and the hardware working together. And on the left side, you can see the individual sensors, and the number of sensors per ranch or farm is going to vary, and that's going to vary depending on the acreage at that location or the number of management zones, like I just mentioned. And each farm is also going to have at least one, but potentially multiple gateways or central hubs that are located on the farm. And the gateway is going to communicate with all of the sensors that we have deployed at the location, and it's going to backhaul all of that information and device telemetry up to a network server. The role of the network server is to consistently manage that sensor traffic. It's updating the data rates of the sensors in real time. It's also managing the security and encryption for all that wireless communication that we have going back and forth. That device telemetry from the network server flows into our backend along with multiple weather APIs where we incorporate historical weather data into our models. We look at regional forecasts for the surrounding geography. And we also look at fire incidents that are within a certain range of our deployments. All of that data flows into our backend. The two remaining pieces are, of course, the customer-facing side of that, the grower app, which Emma mentioned. And the other piece we have that is internal facing only is our console app. And that is a tool that we use that's really useful for us when we are deploying new devices to a location or we're doing installations. We use that for commissioning new devices to our network, getting them organized into the backend, organizing our branches and data in the backend, and also doing troubleshooting while we're on site and deploying with customers. So that's kind of a real high level view of how the entire system works, from the devices themselves all the way to the front end and customer facing aspects of it. And I will pass it over to James for a more detailed look at the backend platform.
Awesome, thanks, Tyler. So his high-level architecture is all about getting information from the ranches and to the backend. So from there, I'll go through a high-level overview here of the Agrology backend system, which looks like this. It receives those data payloads from the network servers and processes those through for archival storage, for historical data, time series data, as well as state management. It also provides APIs for pulling historical data by the customer iOS app, as well as our ML modelers for things like seed data. We also provide a responsive desktop and mobile app that Tyler just mentioned. We built that out for them to manage all of their infrastructure and topologically, that they can use out in the farms as well as in their homes for making sure that their topology is set, which controls everywhere that the backend directs all this data that we're going to show in the graphs in a minute. So if you want to call this a simplified view, this is kind of a simplified view that highlights all the AWS components that we use in the backend. So you can imagine we actually have like many lambdas, many API endpoints, et cetera. But the chief reason to show you this is that, as you can see here, almost everything in the backend is entirely serverless, which has been really great for Agrology's AWS bill, and also for the amount of overhead time that it takes for Verga in supporting all of this. All of our code is 100% in Golang, so we make sure to use all of those features like concurrency, where Golang really shines. So we might do things like write to an S3 bucket, to Dynamo and RDS all at the same time. We can minimize Lambda execution costs, and we have a really cool chart to show you about that in just a minute, about highlighting that transition from Python to Golang for us. Everything's built on an Open API 3.0 specification. That includes the API gateway deployment, all the Golang client libraries. Everything is generated basically from the Open API specifications for each one of the projects. So the entire platform is managed by Terraform. So that way we can deploy repeatably. We can deploy to different environments for test versus validation versus development versus production. So I mentioned that we're nearly serverless. One area where we're not is actually in our Grafana instance. As you can see here, it runs on EC2. So that's an EC2 instance I stood up about 2 years ago. I was freelancing for Agrology, had not started Verga yet, and they wanted to really have something to kind of verify the data that's coming in as we built out the back end. So some more background on that. We were able to kind of bring in that first data from the test sites about over 2 years ago. They were putting all that data basically into S3 for safekeeping, waiting on somebody like me to kind of just come along and provide something more robust. So I started to work on the back end. They already had several months of data ready to ingest. One of my first priorities was getting that data from storage through the workloads and into formats that we needed for making things available, like API querying of that data. So I needed to be able to do things like vet how well we're decoding the payloads, how is it working out handling those workloads over time, how durable that process is. So I stood up that Grafana dashboard just kind of for those reasons. But as I sent it over to Tyler and the other Agrology founder, asked them to help kind of vet the data, they're pretty elated because it was kind of the first time they were able to really visualize all this information that was coming in from the field and understand how well the end-to-end solution was actually working. So that opened up a lot of possible use cases for Agrology with this new Grafana data they had. So one example is being able to report information back to the National Science Foundation. Since Agrology receives research grants from NSF, they typically will send reports to kind of tell about their findings, demonstrate how they're iterating on and improving IoT in agriculture, and convey the full impact of the funding they're getting. So you can see from this screen grab, one way they present findings is by actually taking screen grabs from Grafana and putting those into their reports. So in these kind of examples, they're presenting a few side-by-sides but we'll move to a live demo so you can actually see how we actually use Grafana in real time. So I'm going to exit out of my full screen mode. So here we have a similar chart to what we had in that NSF chart, which is basically how do I compare data like humidity with battery to determine things like when the humidity drops, the battery charge rises, to understand things like how do we improve the quality of our devices in the field and their durability. We do want to take a moment really quick and say that we are running Grafana 8.1. We just upgraded last week, so it's working great for us. All this data that we're going to show uses MySQL and Cloudwatch as data source plugins. MySQL is for our time series database, which uses a custom partitioning solution and rollup solution that Agrology uses, and it performs really well. It lets them get pretty much any data they want with basic SQL queries, which is always really awesome. I'll also note that for this demo, we are using live data, but at the same time, we have anonymized each one of the ranch names so that we don't expose who our customers are and whose data is what, just like we would be able to share this with permission in that anonymous way. One of the interesting things about the Agrology technology is that they do run on those AA batteries like Tyler alluded to. So one of the reasons that they last so long is because each device really reports data in about every 30 minutes. So as they add more devices to the field, we've gone from about I would go with 0.2 reports per minute since January to about 5 reports per minute now. So we're talking about just a 25-fold increase in the amount of traffic in the matter of months. We definitely expect to be talking in terms of requests per second, which I'm sure is a much more familiar metric to a lot of the audience today. And we hope really soon as we grow the technology that we'll be able to move to those kind of metrics. But getting back to this use case where the NFS report was used with Grafana data, we really wanted to be able to show how collecting and visualizing data leads to improving the manufacturing process, including doing things like adding waterproofing where necessary to the device enclosures. So while they did use those side-by-side screenshots in the report, we've built out here basically what we call the data comparator. And that is basically a tool that allows them to select any metric from any ranch and then compare that to any metric to any other ranch on a different ranch rather. So they can see things like these two metrics overlaid on one device really easily and quickly flip through any metric they'd like to look at and make those overlays possible. Some other kind of cool use cases for that is to be able to do things like compare a particular version of a metric from one version of the device to the next to see how they actually perform in the same environments or perhaps in different environments. So those are a few of the data comparison kind of things we can do. We also have what we call a data explorer tool. This is very similar to the comparator. It just includes just the Y1 values instead of a Y1 and a Y2. But one of the things you can see is that we break out the data into several different formats like bars, stacked bars, lines, separated lines, etc. So that way, when there's a lot of different data coming in on a lot of different metric names, each one of those can benefit from a specific look. So we kind of give all of those to the Agrology team in just a few clicks, so they can take the one that they like for any kind of use case they need. If you're looking at irrigation events, for example, we might want to use the stacked bar since that's a count. But if we're looking at something like air temperature, we might be more better off with some of these separated average lines since a stacked count would add up a large temperature that's not realistic. So in addition to some of these highly interactive dashboards like this, we also have some of what you might call classic dashboards that are a little more geared towards things like ad hoc data discovery. So they make very heavy use of this dashboard here that gives a fairly holistic view of a lot of the data that's being ingested and processed. So this dashboard is kind of the one that you're going to peek at when you get up in the morning, when you go to bed at night, just to kind of make sure everything looks good. It's also a critical dashboard for and during after deployments, when you might have devices and sensors that are brand new and just been deployed. You want to make sure they're reporting accurately and reliably during installation, as well as making sure they stay within norms over time. If I go out to say a 90-day view, in this chart, one of the cool things you can see is that we have this air pressure side over here that over a 90-day view is really easy to see a lot more long-term trends, where some of the other things we have like humidity, not so easy to track. So even at like 90-day views, we still get really useful information about this. Another really cool use case for the, let me pop back into my dashboard. Another really useful information dashboard that we have is for ML modeling, and I lost the correct tab. Let me go back to it. There we go. And so for that, Grafana is really immensely helpful in identifying what's the best training data for consumption by Agrology's models. So in this example, you can see over on the right, on the left-hand side of the screen, we kind of have this spike here in the data. And what that is when the sun kind of periodically is in the perfect place in the sky to kind of fool the sensor for a few moments. So being able to kind of see and work around that, those natural anomalies when selecting data is really instrumental in bringing quality forecasts that we can call and what we call synthetic measurements. So our ML specialist might go in, identify that that's probably something we want to exclude, as well as over here for the same condition, but then scrape in here. And now we have the perfect time range to feed into the ML model system to know that we're feeding quality data for training purposes, as well as for running forecasts. So as I mentioned, I do recognize that the vast majority of our viewers today are more from the observability space, more from SRE. And so I would be really remiss kind of not to share some of our Cloudwatch metrics here that really show the operational side of what we do with Grafana to help monitor the health and performance of our backend system. One of the things that we're really interested in is monitoring things like error rates and execution times. Knowing that a more performant backend is less expensive to operate, and the further it can scale. So here on this 90-day view, I'm going to point you to towards the end of May over here in this particular graph, where you could see the execution time for our lambdas going. So I mentioned earlier that we've been in the process of migrating from Python to Go. This is where we actually executed that first migration of one of our major lambdas from Python to Go. And you can see that it actually was able to reduce the average execution time down to about 400 milliseconds from what we would call maybe 800. So having these Cloudwatch events here in Grafana was really useful in being able to identify the exact impact of that execution time when we made that changeover. One cool feature as I was working on these charts today, and I'll flip over to this graph and you'll be able to see it, is this is just basically a 3-hour view of that exact same chart or set of charts. And one thing I noticed was that we do have a little error popping up about every 30 minutes on a consistent schedule. So if you take a look at the timeline of that, it lines up perfectly with when our execution time actually is into very high times, 1 second, a second and a half, 2.5 seconds. So indeed, these few times that the Lambda is taking longer and producing errors is dragging up our execution time average from an optimal 250, 240 milliseconds, we'll say. So one of the areas we're looking at improving here is taking this information today and going back and maybe producing a little bit better of a dashboard that breaks out things like Lambda execution by Lambda function name, so we can identify the exact function and root causes further. Other things we're looking at doing around bringing more life to the way we visualize and slice and dice data is think about things like more cross-ranch centric dashboards, things like having a measure for instantaneous air quality at every ranch, order that from best to worst to see which ranches have better air quality and which ones don't on the fly in real time. We also want to be able to work on bringing Agrology some dashboards for specific areas of concern, like air quality. So we have metrics tailored for just a specific interest all in one place, so we can compare those and see them all together more easily. Aside from that low-hanging fruit, we do have a few larger milestones we're looking to conquer into the future. So I will flip over to the deck again, and we'll move on to the next slide to talk about this. So one of the key deliverables we really have for Agrology, Virga, is the ability to process ML modeling in a much more kind of automated way. Right now, it's a very manual process. Our data scientists will run these ad hoc Jupyter queries in its notebook after identifying optimal modeling data. So we're hoping to maybe extract the best forecast and synthesizing portions out of that notebook without all the visual features. So then we can maybe just provide, say, a container that takes the input and output, allows them to update the model themselves periodically, and put that data in commodity formats, and so then we can batch insert it into our time series database right alongside all the historical data. So then we can do things like chart that ML model data in Grafana right alongside the historical data. So like imagine being able to compare a forecast side by side with another forecast or with real data if you're in training mode. So then we can do things like overlay those comparisons and identify areas where we can improve the model a lot more easily. So we're really excited to be able to bring that kind of capability to Agrology in the next couple months. And we look forward to maybe coming back and showing that off as well. Another area for opportunity is the second column, and that is getting moved off of that EC2 instance I mentioned and onto a more managed service like Grafana Cloud. We've been operating kind of under a don't fix what's broke mantra with respect to that instance. Kind of let it alone and run. We've had 0 issues with uptime, but at the same time, we definitely want to be able to move to a managed service and also shut down that instance, which would save Agrology about $500 a year in operating costs. Lastly, we want to come up with more ways to incorporate AWS telemetry in our dashboard, things like calculating and forecasting the cost of operations on a per device basis, understanding other areas for cost and performance optimizations, like in our archival storage tiers. On top of that, some Cloudwatch logs would be really helpful, like when we turn on device debugging. When Tyler wants to verify in real time that devices are making their way from the network provider to the Agrology backend, he'll usually go to Cloudwatch and do some queries. You might be familiar with something like this. We want to be able to move those things over to something like Grafana Loki, so that we can actually incorporate all of that information right into one place. Grafana that'll eliminate unnecessary logins to our AWS console, and also just kind of keep everybody coming to Grafana for all their needs. Because as you can see, we've made those first few dashboards early on, and since then it's kind of become a useful tool for almost every aspect of Agrology's business operations. So we're really excited to be able to share that story. So with that, I want to say thanks for giving us the time to show all this to you today. And I think we're going to be ready to open the floor for questions.
Not a ton going on in the chat right now, but I have a couple to start out with. I'm always fascinated by hardware development and would love to hear just from Tyler and Emma, just some of the challenges you faced in developing the sensors and getting them out to the farmers.
Yeah, sure. I can start there. Sam, I mean, one of the big things that is still a difficulty today is the chip shortage that's happened globally. So that's been a thorn in mostly my side for about the past year now. It's been really difficult to navigate. But, you know, one of the things that we kind of designed into this product from the beginning anyways was flexibility. I kind of mentioned hardware replacement cycles and how we want to constantly upgrade our sensor technology. So actually we, you know, one of the things we did with the hardware was design separate boards, one that kind of houses the, you know, the brains of the hardware, the microcontroller and the radio. And we have a separate board for sensors that's really easy to swap in and out. But with that, we can also have different iterations of that board with different sensors on it. For example, if we can't get a particular temperature humidity sensor in stock, we can build an alternate version of our sensor board with another temperature sensor that we can get in stock. So those are some of the things we've done to mitigate the challenges, but that has been just for everyone, you know, big companies, startups in particular. It's been really, really challenging to constantly stay on top of, you know, our inventory, distributor inventory, placing orders a lot further in advance than we normally would, you know, has been a real challenge. And just more practical in terms of being out in the field itself, you know, as I'm sure you can imagine, being out there on a farm, it's a tough environment for any electronics device to be in out there on a farm. We have you know, a lot of dust to deal with in places like California in the Central Valley. That becomes a problem. We, you know, moisture obviously is an issue. We have things like spraying that we deal with here, particularly on the East Coast, where our growers are concerned about pest and disease management. You know, so we have, you know, tractors that'll come through the rows of the fruit that are essentially spraying chemicals at our devices at about 50 miles per hour. So that's a challenging environment. We went through one iteration of prototypes, and from there we made a lot of changes to the mechanical design and some to the electrical design as well, just to make the devices more robust, but still making them affordable enough that we can offer these to growers without having any upfront capital costs. So it's been a challenge for sure. You know, having a hardware component always adds that bit of complexity, but you know, you know, we definitely keep iterating and improving over time to mitigate and overcome those challenges.
And I think one, Tyler's great. He's done a phenomenal job dealing with the 3-point turn in the Suez Canal and COVID. So just props to him from a supply chain perspective. He's being a little modest there. He's secured enough for us for a full year next year. So we are very pumped about Tyler's progress on a lot of that. The other, and I think Tyler touched on this, is just the unknown. We had a site go down for, you know, a little while. We went out there and we were all, you know, we're staring at the wires, and finally I remembered seeing feral pigs once when we were out in this vineyard, and we emailed them. We were like, do you have a feral pig problem? Things I never thought I'd write in an email.
Are you sure it wasn't a meme? Like the feral hog meme?
Right? I mean, that's the thing, is you're sitting there going like, is this really real? And then if sure enough, the customer emailed us, goes, oh, we have a huge problem with that. And we realized that a pig had just run through and managed to slice all the cords all at once. So we had to go in and put everything back together. And you know, it was a relatively easy fix, but you have this moment where you're like, I planned for a lot of scenarios, but that wasn't on my QA list. I did not think of the fact that this might happen.
So we got a question
adventure
from TJ in the chat. TJ would like to know if you're currently leveraging Grafana for either the other two pillars of observability. So you're doing a lot with metrics. So are you doing any logging or tracing?
So right now, there's not any of that going on in Agrology's Grafana. We definitely, as I mentioned, plan to integrate some Loki-based parsing of the Cloudwatch logs, if that's possible, so we can leverage some more of the logging side of that. On the tracing side, since we're using AWS heavily, you know, they provide the X-ray distributed tracing capability. So we'll definitely want to maybe look into incorporating that as well into the Grafana stack. However, since the AWS backend works pretty flawlessly, we rarely have any problems with it. You know, the classic observability that a lot of Grafana users are really interested in has not been as much of a priority as you know, bringing around really good visualizations that help them understand their data that's coming in from their devices. So that way, you know, we do have a high uptime. We've lost literally no data, but we also know that we want to improve in those areas, but it's not the focus right away.
Awesome. So we have to switch it over to Jacob for time, but we do have a question from Ron in the chat. If one of you could get to that one. But I want to just give a little big virtual round of applause to our friends at Agrology for showing us some really incredible stuff. Can't wait to hear about your journey next with Grafana and what you're liking about Grafana 8.